Hi there, and welcome to Context Free, where we talk about programming languages. Today, I'm excited to welcome guest Louis Pilfold, the creator of the Gleam programming language, which is a statically typed language for the Erlang Beam virtual machine, among other things. I'm also excited to welcome back co-hosts Andre and Chris, who also had previously joined me for an interview with Jose Valim, the creator of the Elixir programming language. Chris and Andre run the Code Next Door YouTube channel, where recently they've been doing tutorials for Lisp. They'll also have the start of today's interview, and we'll get back to that in a minute. But first, as always, I'd like to do a little bit of an overview of the language that we're discussing. Gleam is a functional language with relatively familiar syntax and expected goodies such as pattern matching. You can find an overview of the language on the website. As a quick demo, I created a new project using the Gleam new command and modified it very slightly. Here's the generated project config file, and here's the main file. All that it had built in was a hello world, which I made slightly more elaborate by declaring external functions for Elixir or for JavaScript, because Gleam can compile to either Erlang or JavaScript, and it can incorporate code written in either Erlang or Elixir or JavaScript without additional configuration at the project level. So here I call the external function greeting and then print out the greeting that gets returned. Here's my implementation in Elixir, where I receive that name and return a greeting string. And here's my equivalent in JavaScript. We can run this and see hello world coming from the Beam virtual machine. Or I can do the same for JavaScript and see the results there, which are equivalent because I made equivalent implementations in JavaScript and Elixir. And when compiling to the Beam virtual machine, Gleam generates Erlang code. Here's that main function calling out to my Elixir function. And here's the generated JavaScript module doing the equivalent here. And again, note that I did not have to do any extra configuration in my Gleam project to include the Elixir and JavaScript sources that I was able to use from my Gleam source. So having seen the demo, let's get on to the interview, where again, you'll find the first part at the Code Next Door YouTube channel. I have a link in the description. And once you're done there, come on back here and we'll finish up the interview. And presuming you're back now, let's continue. And as usual for interviews, I've edited the video and added visuals after the fact.
So during the time where you added support for JavaScript output, what kind of changed in Gleam in order to get that done?
I don't think there were any external changes to the language. I think all of the changes were internal to the compiler, and then we added a flag to say, do you want to do JavaScript or do you want to do Erlang? Which I found really satisfying. I think it is another one of the pieces of value you get from having quite a conservative language design. Gleam, part of the philosophy of the design is that I want to have the smallest number of pieces that fit together the most cohesively, which enable you to do everything that you want to do in a practical and enjoyable fashion. So, very much less is more. And I think that we could add this, really validates a lot of that philosophy. The only place where we've now got a bit of a tension as a result of having the separate backend is that the JavaScript world and the Beam world have two very different concurrency abstractions, or even just primitives. And they're not just different, I think they're fundamentally incompatible. You can't really write code that works on both of them at the same time. So we've got this strange rift where libraries and such can exist on both platforms. But if you've got an application that, for example, makes HTTP requests, well, you have to structure your code in a different way on Erlang to how you do on JavaScript. So that's difficult. And I'm not sure that's possible to resolve. I'm hoping someone does. It would help me a lot, but I don't have any clever ideas for that one at the moment.
Okay, very awesome. In terms of one of the draws for Gleam, actually, obviously, is having that static typing in a language for the Beam, right? Yeah. And there might be other options as well, but obviously more popular languages for Beam right now are still Elixir and Erlang. And Jose Valim in the past year actually made a blog post about possible future static typing for Elixir. And so, yeah, I'm excited too. But I'm curious, how does that relate to how Gleam does it today? And is there any opportunity for what he described, any kind of interaction between the type systems?
I feel so excited that Elixir is getting types. I've been an Elixir programmer for a very long time, obviously a lot less these days. I've got something else on my plate, which has taken up a lot of my time. So it's wonderful that's happening. I hope that Gleam has in some way inspired people to push for types in Elixir. But I don't know any more than anyone else does about the current attempt types. I did know about some of the previous ones before that was public, but this current one is what's going to come from that is to be seen. And as the core team were very clear when they were announcing this, it is to some degree a research project. They think they've got an idea for how they're going to write types on the Beam, on Elixir rather, and it sounds like a really good idea, but no one's done this before, so it's possible nothing may come of it. So we're just going to have to wait and see. But if they do succeed and they do make something that is capable of expressing the sort of things we would expect, like this function takes these types and returns these types, there's a lot of space for interop. There is a working group in the Erlang Ecosystem Foundation, the organization that is responsible for like trying to promote and grow the wider ecosystem, that is focused on interoperability, and types is something that's come up a lot. I could imagine in future that we would have a standardized way of expressing types for modules across all the different Beam languages, much in the same way that we've now got a standardized way of expressing documentation. There's a standard format, and Erlang can use it, and Elixir can use it, and Gleam doesn't yet, which is a little embarrassing, but like in future we'll use it. When one comes for declaring interfaces, we could do the same thing there. And I think that would be fantastically useful.
So speaking of types, when Gleam was first released, there was mention of row types. Does Gleam currently support row types or structural types?
No, we did. In the early versions of Gleam, we had a lot of row-based polymorphism, both in terms of records. We had row typed records that you could extend them, and all the fancy jazz you can do in, I think, PureScript, but not in Elm, at least not anymore. And we also had the whole polymorphic variants thing, which I think a camel has. I'm not sure if. Anyway, we had all these exciting row features, but over time we just sort of decided the right fit for the language was to be nominal for a few reasons. Like, for example, you can get much better error messaging, and I think you can more easily make better tooling with a nominal type system. And I think you can just make a language a lot more approachable, which I think is part of why Elm has backed away from a lot of these polymorphic features. The other part of this is that I think that the nominal system we've got in Gleam maps very well onto the way that Erlang programming works with tag tuples and records and that sort of thing. And since interop is such a key part of Gleam, if Gleam didn't care about interop, didn't care about Erlang and Elixir, it probably would look quite different. But because we want to contribute to this ecosystem and also take advantage of this ecosystem, a lot of the language has been designed around that. There are areas in which structural types would help a lot to interact with those languages, but there's always a tension of, we could add more complexity to the language in order to get some better interop. Ooh, I don't particularly want more complexity, but I do want better interop. So there was a lot of arguing in the beginning, and things being added and removed in order to try and work out exactly where the line should lie. And I think we've come to a pretty nice place now, being pretty much entirely nominal. There are drawbacks to it, but it's working quite well at the moment.
So speaking of adding complexity to the language, Elixir has macros, and languages like Lisp and Forth also have ways of doing metaprogramming. And there are many different ways of metaprogramming. What metaprogramming plans do you have for Gleam? And have you considered anything with dependent types?
This is such a difficult one to answer because metaprogramming is wonderful. Like, I love Lisp and I love Elixir and all these languages that enable to do all these really lovely things. But it's so easy to make something very complicated as soon as you add, that extra expressive power to a language. The kind of metaprogramming that I get asked about most are macros in the sort of Lisp sense, so in the Elixir sense, and type classes or traits. And I look at both of those and they're just incredible sources of complexity if you use them wrong. And with Gleam, one of the main goals is to be very approachable, very easy to understand, try and be like a very stress-free language. Like, we're willing to tolerate a bit more verbosity if it means we can have things be easy to understand. And I really struggle to understand how I would unify, for example, type classes with that. That's going to be really quite challenging because they enable so much brevity and power in exchange for complexity. But they don't actually add any more expressive power to a language. You can always write anything you do in a type class in an explicit way. So I'm not convinced that's the way to go. Macros, on the other hand, that is quite tempting, but also quite difficult for similar reasons. The technical implementation actually becomes a little bit more complicated than compared to type classes because you actually need to evaluate code at compile time. Now that's quite difficult for us, especially since we moved away from an Erlang compiler. Now, if you want to run code inside the virtual machine, I've got to boot the virtual machine and I've got to come up with some way to interact between them. So maybe there'll be a future Gleam VM that is just used for this compile time. I don't know, it's all getting very complicated. And you'd need that as well for dependent types. And talking about language design, as well as thinking about what a feature can do, I think it's really important to think about the design pressures that they put on code written in a language. So if you make X really easy to do, people are going to do X. If you make X look really cool, people are going to do X. And so you end up in situations where I'm going to pick on Elixir a little bit. And this is not because I think Elixir is bad, but it's because I know Elixir very well. I remember in the early days of Elixir, you would have a lot of libraries that would use the using macro. So you could say, use my library name, and it would just generate a ton of code for you. And you looked at what it does, like, this could just be a function. Like, there isn't actually any reason whatsoever for you to do it. But like, the use looks really cool. You know, Phoenix uses it, Ecto uses it. I want to use as well. So I don't think anyone would say that Elixir macros are a bad idea, but I think you've got to think really carefully about what the interfaces are, and you want to make sure that people are using them for the correct things. So of all the macro systems I've been looking at, the ones I find quite interesting are Rust's proc macros and OCaml's, is it PPXs, I think they're called? Because they're quite similar actually in a bunch of ways to the Elixir system, but they're just a little bit more challenging to get started with. And that sounds bad, but I think actually it results in a nice pressure, because like, you won't use them unless you have a really clear reason to use them. Like, if writing a function is easier, you're going to write the function. And that's the thing I want to do. I want the meta programming to be maybe a thing that you consume quite often, but if you are going to create your own new meta program abstractions, I think you want to think very carefully about it and not just do it willy-nilly. So I've not really answered your question. I don't know what it's going to be, but I'm very interested and I think about it a lot.
No, that was great. That was a hard question.
Awesome. So in terms of a little bit of metaprogramming, I actually haven't looked closely at the implementation of it, but I played around with it some. There's numerical Elixir, which is one of the cool things that's happened in Elixir recently. And one of the things it does is provides automatic differentiation. Everybody wants to differentiate their programs now, right? And it can do that for functions written in Elixir. Can I interact with NX from Gleam? Can I use NX effectively, and or can I get differentiation from my Gleam programs? Or is it something like that's hard to keep compatible across the ecosystem?
It's an incredible, well, this really shows actually how maybe I'm wrong in everything I've just said. Like, maybe you really do want like these super accessible macros, because like, wow, what a brilliant use of macros that is to enable something that everyone said, oh, the Beam's really bad at this. And the Elixir folks just said, no, it's not. Here you go. Look, we've made this amazing thing for you. Now it's one of the best in the world. Like, that is absolutely amazing. Hats off to those folks. And we don't have anything equivalent at all to that. So you can't, for example, write Gleam code and just magically make it super fast and numbery and all that stuff. But one thing that is very cool about Gleam and the Gleam build tool, which supports compiling Gleam, Erlang, and Elixir, is that you could have a project that is both Gleam and Elixir. You could write, say, the majority of your code in Gleam because you want to, use types for your business logic. But then you could slide across into numerical Elixir and just have these core numerical modules be written in Elixir, and the Gleam build tool will be able to compile all of them. And because we've got a very good interop story between Gleam code and Elixir code, and there's no overhead and it's quite easy to import functions, you can just call across into each other. So I think that would probably be like the best way to do it, rather than duplicating the work and trying to do the same thing in Gleam, which would be challenging because we've got a lot less just developers working on Gleam than Elixir does. Let's try and leverage the good things that you can find in the other Beam languages.
Makes sense.
So what's most exciting in the future of Gleam, and do you have an idea of when Gleam 1.0 will be coming out?
What's the thing I'm supposed to say now? When it's ready? I think that's the standard answer, right? It's tricky. There's a lot of things I want to add, but not many of them are to the language, actually. So I think in terms of the language as it stands, there's a few things missing, like exhaustiveness checking isn't exhaustive, which is kind of rubbish, really. So we need to finish that off. And then there's some debate about whether we add optional arguments or not. But with those two things, I think that may be pretty much the core language complete. but everything else is all around tooling. We really, really, really want to have excellent tooling. Unlike most languages, we consider editor tooling, in particular the language server, to be actually a core concern. That's something taken on by the core team rather than something we expect the community to build. So there's going to be a lot of work into that, and a lot of things I think are going to be exciting are going to be around the editor experience. If you've used the Elixir language server or something and thought, that's pretty cool, I'm hoping that we'll, in a year or two, be able to blow you out the water, because the Gleam compiler knows so much more about Gleam code than the Elixir compiler knows about Elixir code. And we should be able to do really powerful things that you couldn't do elsewhere. Being able to generate your JSON decoders and encoders and perform powerful refactorings and all that sort of stuff that you'd find traditionally in, I don't know, perhaps in a Java or the Rust language server. We should be able to do something quite similar to that. But it's not very exciting to talk about. I think it's going to be very impactful, but I think people will just go, oh, yeah, okay. It's tooling that really works and you don't think about and just enables you to get your job done. That's what I'm quite excited by. Oh, and as for 1.0, I think we could probably do a thing where we consider once you've got these last little bits of the core language done, we could do like 1.0 for the compiler and then perhaps version the build tool separately. Maybe that's something we could do, because there's actually very different levels of maturity between the editor tooling and the compiler itself. And I think that'd be a nice statement to people about how usable the language is. People are using it in production. I use it in production. That doesn't really say very much, does it? But like other people who aren't me use it in production, they feel comfortable enough betting some of their livelihoods on it. But I would like to just have a bit more person hours of use in the system, really, because I feel very confident about where the language is, but it might be that I'm just wrong. And it would be great to have more people running Gleam in productions and say, yes, it's all going really well, if we're happy with it. Or actually, maybe a big chunk of them turns around and say, this one particular thing sucks, that's causing us a lot of problems. And if we're not 1.0 yet, we can go, oh, okay, cool, we've learned something. Now we can work out how we're going to fix that. So, no idea.
Any closing remarks?
Thank you very much for having me on the show, guys. It's been really fun, and I watch and enjoy these, so it's very cool to talk to you. I'm gonna be a bit shameless and plug a little bit. I work full time on Gleam, and that is purely because people are very kind to sponsor the project. Some commercial sponsors such as Fly.io, and lots of individuals who just donate a few dollars a month. So if you think that Gleam is a thing that you like and you want to support it, please consider sponsoring on GitHub Sponsors. So thank you very much.
Awesome. And thank you also.
No problem. Thank you.
And if you missed it, do make sure to go catch the first part of the interview on the Code Next Door YouTube channel. Link in the description.